Hello everyone, and welcome to part 2 of dividing polynomials. In this video we're going to be looking at another way of dividing polynomials. We're going to be looking at synthetic division. Okay, and just like in part 1, this is designed to be a head start kind of video, giving you a little bit of exposure to something that you're going to definitely use next year. So part 1 looked at dividing polynomials but using the long division method, and it was great. But as you can see in the previous video, it takes up a lot of space on your page. And so it will actually, if we had a single question, could actually take up a half to even a full piece of paper, which for a test or for a pile of scrap paper is not very efficient. So because of that, synthetic division kind of came to be. And so we're going to start by showing you a setup here, okay, and how you go from a simple question to a synthetic division setup. So we have 2x cubed minus 6x squared minus 5x plus 3 divided by x plus 3. Okay, so we start off by creating this vertical line here and going all the way over. Okay, now if this was a lined piece of paper, right, I'm just going to do this off to the side here to show you. Okay, this method will only take 3 lines on your sheet of paper. So it would actually take up, if you probably have a question with an allotted space in it, this would actually take up just a little bit of that space. You wouldn't be filling that entire space with the entire division like you might with the long division method. Okay, so we have, okay, so once we do the vertical line over, okay, we have to now put in our numerator. So our coefficients of our numerator. So we put in the 2, the 6, the negative 6, the negative 5, and the positive 3. Now, if the bottom part here didn't go far enough over, okay, once you put the 3 in, just make sure that when you come across here, okay, you come across far enough that it stops just after the 3. Okay, create a little box vertically below the 3, and that's where your remainder will kind of sit. Okay, the next thing you want to do is take the x plus 3, because that's kind of like our denominator. Okay, and we're going to set it equal to 0. Okay, and we need to do this because we need to isolate our x and find a value of, what value of x would actually make this true. So if we have x plus 3 equals 0, we can subtract 3 from both sides, and we find out that x equals negative 3. Once we have this, we take the negative 3 and we write it right up here. Okay, now that we have our proper setup, okay, I'm going to use an example on the next page to show you what to do after this. Okay, so we're going to use the exact same example that we did from part 1 of dividing polynomials. Okay, it's still going to be 3x squared minus x squared plus 2x plus 4 divided by x plus 4. Okay, and this time we're setting up like a fraction. Okay, so our step 1 is to do the setup. Okay, so I would come on my lined piece of paper, do a vertical line down, horizontal line across, okay, and then I would grab my 3, write it here, my negative 1, write it here, my positive 2, write it here, and my positive 4, and write it there. And maybe I did come up short, so I would just extend it over to make sure that, just like before, it stops just after the 4. I write a little box in here, and I'm ready to go. Okay, I need to grab the denominator, set it equal to 0, isolate my x. So in this case, x plus 4 equals 0. So if I subtract 4 from both sides, I get that x equals negative 4. Once I have the negative 4, I can write the negative 4 up here. Okay, and I can start my process, or start steps 2, 3, and 4. Okay, so step 1 is now done. Step 2 is basically a pull down and multiply. And so what that means is that this first term, or the first number, the 3 gets pulled down, okay, and written down here, okay? Once it's pulled down and written down there, right, we have to now multiply. So we go minus 4 times 3 gives us minus 12, okay? And then we're on to step 3. So step 3 is we got to add or sum. So we go minus 1 plus negative 12 gives us negative 13. Okay. And then we have to multiply again. Okay. And so we go minus 4 times negative 13 gives us a positive 52. Okay. And then once we're at that point, we kind of repeat steps 3 and 4 kind of as a circle until we get to our remainder. So 2 plus 52 is 54. Okay. Minus 4 times 54 is negative 216. And then 4 plus negative 216 gives us negative 212. Okay. Once we have all this information here, we can actually write a final answer for this polynomial problem. Okay, and so this numerator divided by this denominator equals 3x squared minus 13x plus 54 minus 212 divided by x plus 4. Okay, and that's how we do that one. Okay, and like I said before, the pros are the advantages of using synthetic division is that it only takes up 3 lines on your sheet of paper. It is quicker. Okay, you don't have to write a lot of the variables. So like remember in long division we actually had to write like x cubed, x squared, x, and so on and so forth. Yeah, we don't have to do that anymore, so it's a little quicker. The disadvantage though is that I find it's easier to make a mistake, and so when you're dealing with doing all the multiplication and everything, or doing in this case the addition, sometimes you will encounter an error where you have 2 operators next to each other, like a plus minus, and you forget kind of how to combine them, or you just glance over them and you keep going. So you want to make sure that yes, it's quicker, but you want to be very kind of on the ball, not distracted when you're doing it, because it's very easy to mess up an operator, and that error could dramatically change your answer. Okay. All right, let's do one more example. Okay, so here we have an example of x cubed plus 125 divided by x plus 5. Okay, we're going to do the same thing again. So we're going to go down 2 lines on your paper, across, okay, and we're going to write the 1 that's in front of the x cubed, the implied 1. We write it right here, okay. And then, because we go from x cubed to a constant, we need to actually have placeholders between x cubed and the constant. So x cubed, x squared, x, and the constant. We have placeholders here, okay? And we do this so that the reader doesn't misinterpret the question. If you did 1 and then 125 right behind it, you're telling the reader that you have maybe an equation that's x cubed plus 125x squared, or maybe you're telling the reader that you actually have x plus 125. In both cases, that's not what we have. It's very confusing, and so adding the placeholders here will make a huge difference. Okay? All right, let's take the denominator now, set it equal to 0, isolate for our x by subtracting 5 from both sides, and we get that x equals minus 5. This minus 5 goes right here, right in line with the 1, 0, 0, and 125. And then from there I do steps 2 to 4. So the 1 is pulled down, written here. And then I go minus 5 times 1 is negative 5. And now I go 0 plus negative 5. Okay, it gives me negative 5. Okay, and then I continue the process. So I'm going to go around and around those two steps until I get all the way to the remainder here. So minus 5 times negative 5 is a positive 25. Okay, and then 0 plus 25 is 25. So I'm just trying to make these a little thicker. Okay, now negative 5 times 25 is negative 125. And we go for one more time, we go 125 plus negative 125, and we get no remainder. Okay, this means that if we do x cubed plus 125 divided by x plus 5, our final answer is x squared minus 5x plus 25. Okay, we don't need to write a plus 0 over x plus 5. That makes no sense. And you should know at this point that any 0 divided by anything is 0. Okay. If you have a question in your work that results in an answer that can then be further factored, maybe it's a difference of square, or you just simply unfoil it. Okay, do that. But in this case, we don't have that. Okay. So if you need questions to kind of go through, there are a couple of questions in the textbook or in the notebook, sorry, the workbook. So it's the 2006 workbook. Okay. And so questions like this where we have question 1, divide the following polynomials and in each case express it in this form and in this form. Okay, and so we have A, B, C. Okay. There's a couple of questions over in question 3. Okay, so 3A, B, C, and D. Okay, increasingly more challenging, yes, but good practice. Okay, and then if you're feeling really brave, we have this question up here, this numerical response question. Okay, so when the polynomial 2x cubed minus 5x squared plus 4x plus d is divided by 2x plus 3, the remainder is negative 6. Okay, it's just simply asking you for the value of d. Okay, so that would be considered a challenging question, but kind of once you kind of look at one or two of those, it's not so bad. Okay, and then a really hard question, comparatively, is this one here. So when the polynomial ax cubed plus bx squared plus cx plus d is divided by 3x minus 2, the quotient is 2x squared plus 2x plus 3, and the remainder is 7. Find a, b, c, d. That would be considered a really hard question because of how many variables are floating around and what you have to do with those variables, okay? So, little hint here is that if you're divided by this and this is your quotient or your answer to a division, okay, and the remainder is this, right? We know that if this is your answer, plus 7 divided by this, you can start doing BEDMAS and multiplying and grouping like terms to go from that there up into the form of an x cubed, and that should actually allow you to find out what a, b, c, and d are. Okay, they should be single numbers because you only have one box for each of these. So if you mess up and you get a is 14, that can't be because you only have one box for a. Okay, if you have any questions, don't hesitate to ask. Thanks. Have a good day.